Welcome to this final episode of INF-3910. Congratulations if you have made it this far. So far in this course we have been learning a lot about new stuff about functional programming. It's been pretty theory heavy in the beginning, but now towards the end we have been moving more and more towards the practical stuff. How to actually develop and deploy software written in F#. And this final lecture will sort of take this to its conclusion and discuss a topic that I think is super important. It's a very big topic. I won't be able to cover more than a tiny little bit of it. But this is something that I think is very important, and you probably already know a lot about this because there are probably courses at the university covering these things. But that's DevOps and continuous integration and continuous deployment. So in this final episode, we will look at some updates I've made to the code. I've improved on the demo code I've been using the past few lectures. Prepared it so that it can work as a stencil for a lot of typical use cases that you will find, and then we're going to add some DevOps to it and see how that works out. So the idea here is basically, I'm not going to go through any big details on the code or any of these things. It's more a way of pointing you in the right direction, so that you see where you can go. You can go and download the demos, and you can study them, and you will find examples of how to do a lot of things. I would guess, like for a lot of typical business applications, the example contains nearly 90% of the most important stuff that you will ever need. So, DevOps. So what is this thing? So the whole idea really behind DevOps, really, if we go back to really the fundamentals of DevOps, is to deliver value to your users as quickly as possible. Now, if we sit and code and work on an assignment that we have, nobody gets to use that thing. That is unrealized potential value for someone. So if we sit and code for 6 months and then we deploy it, and then we fix some bugs, and then we go back to getting the next features out, and we sit and code for another 3 months or 6 months before we deploy. There's always this huge delay before whoever wants to use your features can actually get their hands on them. And DevOps is really about delivering value to your customers, to your users as quickly as possible, to so that they can start using your things and get the latest features. When this means that the whole key to this is to have really short release cycles. So back in the day, it used to be like maybe you had a release every year, maybe every 6 months. Big thing. Everybody stopped working, and you would sit and spend days and preparing everything, and then deploy your system into production and carefully test and all kinds of problems. And now we want to get this down to having actually tens of deployments per day. And this has a huge impact on how we work and how things work. And it might sound like slightly crazy because it's difficult to deploy software, so we want to do it so many times a day. But the idea is that if we do it very many times a day, then it becomes such an easy task that nobody even thinks about it, and the whole big problem of deploying software just goes away. And as soon as you have created a feature, you push it to Git, and 10 minutes later your user will have it, perhaps. So this is the DevOps comes from development and operations, and to some extent we can say that it used to be that developers wrote code and then they gave it to operations and they would sit and massage your code to get it into production. Now developers are basically responsible for the code all the way up to it being deployed on a machine. So it's the developer's responsibility to write the code and to deploy it. And then if you have an operations team, they will start monitoring things and they will just make sure that things are running smoothly and hoard servers and whatever. But sort of this is sort of coarsely the distinction here. CI/CD. So this is sort of at the core of DevOps in software development. Continuous integration, continuous deployment. And to do this, it means that we always, so continuous integration will mean that your latest feature will make it into the master main branch that is being tracked continuously. So basically it should be, you push a new feature, it goes to pull request, somebody reviews it, it gets tested, and everything seems to work. It gets merged into the master branch from where everybody else can sort of get it when they do their pull. And from the master branch, it goes to the continuous deployment. So immediately as something changes with master, it gets picked up and put into production or into staging, and from there into production. And in order to achieve this, we need to have a fully automated pipeline so that we push code, it goes to a build server, it runs the tests, it does all the checks, and then deploys it. And the good thing about this is that if you do this, you track your production environment very, very closely. Because even in a small 1 or 2 person project, what you will find is that if you sit and work locally with your code and you compile it and test it and you run it, it will work on your computer. It will not work on the next person's computer. Not even if we say, well, but it's .NET and it's JavaScript and it should be portable and stuff. Yeah, but these environments are slightly different. Somebody's running a Mac, somebody Windows, Linux, there's a difference. You made some little local hack for some database thing. You changed some local passwords, whatever you did. All of these things build up and makes it really hard for the next guy to actually run your software. And this we see in practice all the time. And it's wasted time and it's wasted effort and it's really, really frustrating. So this is a good thing with this CI/CD thing. It forces you to track the production environment. That's what you code against. You don't code against your local computer because that's meaningless. You have a system where you deploy your software and you code against that. The other thing that you can get with this is really consistent build environments, and we'll talk about that in a little moment. So that you always, everybody is building on the same type of environment and using the same environment. And the final point here, which is also very important, is that now if you automate everything, you're actually, the whole production process is documented in code. And if something changes, your deployment system will break and your CI/CD pipeline will break, you will immediately notice, you will have to fix the code, and that means that your documentation and your code and everything is always in sync, because otherwise it doesn't work. Important. So I have made some updates to the web app, the silly little person web app that I've been using, mostly because I wanted to give you some really important examples of how to do common tasks, which are not necessarily difficult, but might be a little bit tricky. So the main thing I have added to the server is authentication and some form for authorization, but mostly it's authentication. So I've added an example how to do very simple cookie authentication. You can look at the code and see how it's done. It's very easy to change it to use JSON web tokens or something similar. There will be different workflows for authentication or authorization, a little bit depending on if you use cookies or JVTs, or if you go for something like Kerberos or OAuth or OpenID and these things, because some of these setups will actually do the actual authentication for you. So in this cookie authentication thing, we need to check, is the user authenticated? If not, send him to a login page, fill in credentials, check the credentials, and then authorize him. Whereas if you, for example, want to use Azure AD or Facebook or Google login, basically the whole system will automatically send you off to some login page at Google. You fill in your credentials and hopefully get authorized back automatically. Another thing which can be sort of tricky when dealing with these JavaScript applications is that they're not web pages, they're applications. So things like back buttons and stuff will take you suddenly out of the whole application, and that's kind of cumbersome. It's also a little bit cumbersome to navigate between different types of pages, although you can do it, but it's kind of hackish and it doesn't feel natural. So I've actually added an example using this fairly new Felice router component that I really encourage you to check out, which allows us to do basically have something similar like a normal web page, but within the context of a single page application. So suddenly we can actually use the back buttons and things will work out nicely, and we can redirect the user to another page and then back to the main page and so on. So this I use. I've written a login component so that when you start the app, you can't edit anything, and then you can log in, and when you have logged in. And when you log in, you will get redirected to a login page, and when you have logged in, you will get redirected back to the main page, and suddenly you have access to the edit box. The whole login page I've written just as an example using another Felice library, which is called Components, which allows you to create sort of standalone React components using the MVU type approach, which means that you basically can write something like your own HTML tags, but internally it runs its own little MVU loop. Also updated the tests so that the tests will also do the UI testing and check that the login process works and so on, and run in a headless mode. So then I have added. So that was just the code. So now I've added also some updates to the environment, sort of the stuff around the code. And first thing I've done is that I've taken the demo safe app and I've moved it into its own project so that it's easy to just have that specific app. And you have the URL on the screen. So go and check it out. I've added a Docker file to it. So now basically the procedure is that we will run fake build and -t release to build the code, and that will produce a directory called deploy, and then the Docker file will just take the contents of that deploy folder and move it into a container and wrap it up in the right way so that we can run it in a container very easily. I've also modified the standard dev container Docker file. And so a dev container is something that when you create a safe template, you automatically get this dev container. And the idea behind the dev container is that it's essentially a container which should have your complete development environment in it. So in our case, it would be the latest version of .NET Core. We might want to add, of course, Fake and Packet and some other tools to it, Node, Yarn, and so on. And then Visual Studio Code has this possibility that you can just say, okay, I want to use a dev container instead of the local environment, and you can just choose the dev container, and it will run everything from within the dev container and mount up all the volumes and everything for you. Very convenient. You don't have to install anything at all at the machine that you're working on. All you need to have is Docker, and then you can just, and Visual Studio Code, and then you just point at the dev container, and you have a consistent development environment. We're going to use this dev container for two purposes. One is to use it as a dev container. The other is to actually have it as our sort of stencil for how to build the code in our DevOps pipeline. So we'll use that Docker file to create sort of the SDK for the DevOps pipeline. There are plenty of DevOps tools and CI/CD tools. We are going to be using GitHub Actions, which is a fairly recent addition to GitHub, but they work really nicely and they're nicely integrated. Still a bit primitive, but it's coming along. You can use Travis or Jenkins or GitLab CI or whatever you want, but in this case we're going to be using GitHub Actions. And finally, I've added a Helm chart. So for those of you who are familiar with Kubernetes, Helm is a sort of convenient way of deploying more complicated setups onto a Kubernetes cluster. I won't be demoing Kubernetes clusters and how to do it, but when we run our pipeline here, it will actually deploy to our local Kubernetes cluster at work, as well as onto my machine in the demo. I'll show you in a second. So the build pipeline that we're going to be using goes like this. First thing we need to do is to create a sort of base image for building everything. Now there are many ways you can do this. You can just basically say, okay, whenever you start up to run your DevOps pipeline, just install all the dependencies and everything. But that takes a lot of time and wastes a lot of resources, a lot of network traffic. So what we want to do is that we want to set up a very simple thing once. Every time the dev container changes, it's going to pick up the build pipeline is going to realize that, okay, now the sort of base image for building the whole system has changed. It will run Docker on it, Docker build, and it will build a Docker image and push it to a registry where we can then pull it and use it to build. But this only happens every now and then, because quite seldom we change the build environment. It's like when you update .NET Core or add some other dependencies, you might want to change it. Then the next stage will be building the code. So that's essentially downloading all the NuGet packages, downloading all the NPMs. We're going to cache those so we don't have to do that every time. And then run fake to build the whole thing, and we will get this deploy directory containing the whole project. Then we're going to test it, and if all this goes well, we're going to release it, and the release will simply mean that it's going to take this deploy folder and create a Docker container out of it and push it to the Docker registry so that we can then either deploy it locally or to Kubernetes. So this is the idea that we have, the scheme that we're going to go through. Yeah, so I already gave you the URL to the web app. You can go and have a look at the details there. I won't go through much of the details. I will be using another repository, which is this Action Runner Kubernetes, because by default the GitHub Actions you can run them in Azure, or you can run them in just GitHub. So for open source repositories, there are no restrictions. Very easy, very convenient, very quick. We're going to use both, but you can also have local runners and run them on your computer, or if you have a data center, or if you have some resources elsewhere, you can install these runners and have your build process run there, so that you don't waste resources on GitHub if you are paying for them. One of the problems with this scheme is that this GitHub Actions runner is meant to be running on basically bare metal or a virtual machine. So it needs basically a full operating system. Now, I don't want to do that. I want to use Kubernetes, which means that I have to take the whole thing and put it into a container. And that process becomes kind of sort of nasty and tricky, and there's all kinds of caveats with doing that. But I've done it in this project, and it allows me to run these actions runners in Kubernetes and locally on my machine. So I will show you in a second. I will fire up a runner running in a container on my machine. Although that's not what you normally would do. Normally you would fire it up on your machine just by hand and be happy with it. But me being me, I'll make it more complicated than necessary. So that's the idea. So let's go quickly to the code and have a quick little look at what this looks like. So the first file we're going to look at that we have added is the Docker file. And if you're not familiar with Docker, it's very easy to learn. It takes about 15 to 20 minutes to get the basics and learn it. Super useful, very important. So in order to create our runtime deployment image, the one that we're actually going to deploy to our Kubernetes or local machine, is going to be based off this base image, ASP.NET standard latest version 3.1 image. Now that image, if you're going to do any kind of SSL on enabling on your Kestrel server, ASP server that you're running inside this application, it comes with a slightly strange SSL conf by default, this container from Microsoft, which will break everything terribly for you. So then we just remove this openssl.config file, which will make things sane again. Although in principle, I guess what Microsoft is doing is the right thing, but things don't play well yet. The app is going to be inside the container residing in /app, and then I just copy this deploy folder into the app folder, and this deploy folder is the one that I get when I run fake. And then I say, well, okay, just then after that, just run the server and it will start up. So this is the most basic sort of Docker file. The other Docker file is much more involved, which is the dev container Docker file. Let's look at that. So the previous one was based on the ASP.NET runtime image. This one is based off the SDK image, which comes with the whole compiler and everything that we need. But then we need to add node, we need to add some keys, and we need to add yarn, node, of course, and some tools. I also need to be able to run these UI tests in headless mode, so I need to install Google Chrome on it and tweak that a little bit. Then we clean up all the stuff that we don't want to have inside the container once we run it, because it gets big. Then I add packet. Then I add fake, and I also added the .NET retire and JS retire, which are nice tools to have to check that you don't have any vulnerabilities in your dependencies. Update the path, and copy a setting, VS Code settings, if you want to use this with the dev containers. And this is the one. This Docker file here is going to be the basis for our sort of build image for building the project, which we'll get to in a second. So let's go to the server. and just very briefly have a quick look at what I have changed on the server side. So let's go down to the API, and previously we had created this REST API where you had get, put, and delete. Now I've made the get part is up here, and it's freely available. So it's only if you want to add or change or delete something that you need to be authorized. And the way I've done this is that I've added this authorize filter or pipeline thing to this. So when this hits, it's going to check if the user is authorized. If not, there's going to be an error. And this has been authorized has been implemented the following way. It basically just calls a giraffe function, requires authentication with the cookie challenge. And here, if you have something like JVT or OpenID or something, then you're going to use those challenges in place of that. And you can look at the details. This is somewhat hairy how these things actually work, but they are fairly well documented. But I guess you could use this more or less as a stencil. So we can go down and have a little bit look on the pipeline. The basic web server hasn't changed at all. The only thing that really has changed here is in configure app. I've added use cookie policy and use authentication to the pipeline. And in the configuration of the services to this dependency injection container, I've added configuration for authentication using cookie authentication, and the authentication options is defined up here, and the cookie options is defined there. That's a little bit about where it's going to check for, what it's going to check for, and redirect URLs and stuff. So that's the sort of bird's eye view on this authentication process. One of the important things here is that we have added a API for logging in, which goes to sign in, which handles the actual signing in process. It creates the user identities and principals and all these things that are needed. And I'm not going to go through how that works. You can read the documentation from Microsoft on those things. It's fairly extensive, and it's going to take you a couple of hours to really understand what's going on there. In this example, we're going to validate any user giving any username and whatever password. You're good to go. So we don't care. But obviously you shouldn't use that for production. So, but it's nice for testing. So that was the server and authentication pipeline. Now, here's the final little thing. So this is the login page. It's extremely straightforward. I pretty much nicked it off some Bulma template thing and just turned it into Felice Bulma, most of it. So you can have a look at how that's implemented. The only thing that is sort of special with this code, it comes here right at the end, is instead of just having this as a normal submodel to the sort of standard MVU loop, I actually create a new React component using React function component, and then you give it the function and with some stuff. So, and this just makes it into a completely self-contained React component. And you can pass in some data from the parent that it needs to render. And what I in particular do is that I pass in a dispatch function so that this login page, when I click login, it can dispatch back to the parent. That's the most sort of important thing. So then I can just start this thing, and then as I dispatch back, it will get garbage collected and disappear. Yes. All right. So the final thing that we're going to look at, and this is where it starts getting hairy. This is the definition of the DevOps pipeline using GitHub Actions. And you need to go and read up a little bit on GitHub Actions. It has very good documentation. There's plenty of stuff there. But in my experience, every single CI/CD system that I have tried and worked with, it's a lot of trial and error to get it to work. Like the tiniest little mistake you do and it will break. It will break and it will break and it will break. So in order to prepare this exercise here, I didn't have any experience with GitHub Actions, so I actually built up something that we can more or less use in production. So it's a fairly advanced version of it. You could make it much simpler, but I really wanted to sort of try it out and test how things work. Now, I've spent 4 days on this. I have spent hundreds of commits on this. So before I actually released this to you, I did some rebasing with Git and removed, like I had these debugging blah blah 60 of them in a row. So I squashed them into one, just trying to get these things to work. It's nasty. And this is my experience with each and every one of them. They usually use YAML as a specification language or sort of specification format, and it has zero type safety. There's like, you make a slight mistake and then you just get an error on the screen and you go fix it and you go to something else, and then some permission problems, and there's it's a nightmare, to be honest, but it's worth it. Trust me, it's really worth it, because once you have it up and running, you can sort of copy it from one project to another, make small changes, and you will have a CI pipeline working for you for all your projects, and you're constantly getting things into production. So let's have a look how it looks. I'm not going to go through any of the details, but basically you give your setup a name, because you can have, so this resides in a top level folder called .github Workflows. There's also one that you can call Actions, where you can create your own sort of modular actions that you can use and reuse in your project. We're not going to look at those. And then there's a main YML YAML file, which is my main workflow. You can have multiple workflows and so on, make it arbitrarily complex. We have one workflow, which is called main, or it's actually called build. You can set up some global environment variables. So here the project owner is me, project name is going to be web app. For deployment to Kubernetes, I'm going to use our internal name kube2. So the way this is going to work is that I have a local GitHub runner running on our Kubernetes cluster, and as this gets sent into that, it's actually running inside our internet in the cluster and get picked up, and it has access to Kubernetes credentials and secrets, so that it can deploy this thing to Kubernetes from the inside. Yeah. Then there's a little trigger here, event thing, where it says on. So this says, when should this workflow be triggered? And there's plenty of stuff there. You can have events like on somebody creating an issue, and on merge requests, and blah blah blah. Long list. Go and read the documentation. We're going to simply have on pull requests and on pushes, only on the master branch. So if you're pushed to any other branch, this won't run. So if I push the master, this goes. And then comes the actual meat of the pie, jobs. And the first job we're going to do is create the SDK. It says run on Ubuntu latest. This means that this will run in GitHub in their data center somewhere. It will fire up a virtual machine with the latest Ubuntu image, and then it will execute the following steps. It will check out the code. It will then actually check the hash of the Docker file and see if it has changed. If it hasn't changed, it will just skip building the SDK, because then it's already available. But if there's a cache miss, then it will actually build an image using this dev container Docker file. Then we're going to build the actual code. I called it build release. You could also have a build debug if you want to make one with debugging information. And this one is going to be running in a container, and it's going to be running in the SDK, the container that we just created. I use some environment variables, and now we say this one runs on self-hosted. So this will be running most likely in our Kubernetes system. I will soon fire up a local runner on my PC, so this could actually end up running on my PC here at home. And then it will check out the code. It will try to check out the cache for the NuGets, or if they don't exist, update the NuGet packages. The same for the npms, and then it will run .NET. And then we'll run fake build release, and then it will upload the result to a artifact cache. The release is going to again be running on GitHub, and it will download the recently built deployment bundle and wrap it up into a Docker file and push it to the GitHub Docker registry. Same pretty much for tests. It will run in our data center. It will again use the SDKs to run all the tests. And then there's the deploy stage. Now the first one I have here is for deploying in our local Kubernetes setup according to how we do things normally. You can ignore that. But the final one is deploy local Docker. And it says runs on self-hosted, and then I've added an extra label local so that I can say to the process, okay, this thing here should run only on runners which have this local label. So the one I will create on my machine will have this local label, and then I know that this will come to my machine. It says depends on release, so that we know that we have built and released the code. And it will just simply run docker run expose port 8085 of the latest version of this app. So without further ado, let's start the runner. Here you can see is my action runner Kubernetes project. I have created a little shorthand script because it contains secrets and I don't want to expose them. So I'm just going to say local.sh. This will hopefully start a container which will register itself with GitHub Actions. It will do some authentication, and it will get a runner token from GitHub. And if everything goes well, it says listening for jobs. So that's pretty good. So now let's go to the web browser instead. So here you can see here's the project. Here's all the code. It says build failing. It's not quite true, but almost. And now we can go to settings on the project and check out the runners. So here we have this actions tab, and we can see that I have 3 self-hosted runners available. These 2 are running in 2 different namespaces on our local Kubernetes, and the final one here is actually the one that I just started, and you can see that it has this local label on it. So that's the one we're going to be using when we are deploying to my machine. And we can also check here, I can say local. Okay, let's see. I need to press. Yeah, we can just say localhost 8085, and we can see that site can't be reached. So there's nothing running on my machine currently that we can use. So here are runners. I'm not going to push the code. I'm just going to simulate pushing the code. So I can go to this Actions tab, and you can see that here's the last thing that I did, cleaning up things a little bit. And I'm just going to rerun this manually from the browser. It's exactly the same thing that would happen if I would make a push. Then this would run automatically, instantly. As soon as it receives it, it will start kicking this next runner. So just go here, rerun all jobs, and then hopefully this will play out nicely. So the first thing it will try to do is to create the SDK. We might have to wait a little bit because this is going to run in GitHub, and there might be a queue. You see that everything is going nicely. It figures out that we didn't have to do anything to the SDK. It was already there because it checks the cache. We can open these things and look. It says cache restored, and then we know that, okay, we don't have to do anything. So next stage is build the release, and this is now going to be running most likely in our data center, but we can check because I can see instantly here in my environment. This one says listening for jobs, so it hasn't received anything yet. If it would have received this job, it would say accepted job or something like that. So now it's restoring the NuGet cache. So this will take a little while to complete. One of the things that you can do with these things is that you can have things run in parallel if they can run in parallel. Obviously, you can't release your software before it's built, so there's a certain order to things. But for example, tests can be. So what I do is that I will release the software, which is the release is just creating a Docker image and pushing it to a Docker registry with a unique label on it based on the Git SHA checksum, and then I'll run the tests, and then if the tests fail, I know, okay, I have a problem. But in principle, I could also say that, okay, I need to have the tests to go through in order to create the release. So these things can take a little bit of time. Sometimes these caches and artifacts in the cloud are painfully slow, so things take forever. Let's see. So there we got, yeah, I had to download like 300 megabytes. Now comes the restoring the npm packages. I'm not actually pretty so sure that there's any point in restoring. NuGets are big, but the npms are fairly small, so it's faster to just reinstall them every time. See. See how this goes. So go install dependencies. Everything should complete quickly, and then it will build the project. So normally we wouldn't be watching this. This is pretty sort of slow and boring television. You just go and see what went wrong, if anything went wrong. But there's a certain pleasure to watching it get all green also, which is hopefully what we will get now. So now you can see now it started building the project. It built the server. Now it's running the Fable compiler for us. And this is of course all happening in. Let's see if it's happening locally. Nope. This is happening in our Kubernetes cluster in Trondheim. So I'll just pause this for a little while, and so that you don't have to sit here and watch this painfully slow process complete. Well, here we go. Now it's uploading. What the heck? Let's just watch it. Then it stops containers, checks the caching stuff, and so on. And there we go. So the build went nicely, and now it kicks 2 parallel jobs: release and tests. The one that we are interested in really is release, because as soon as release completes, it will deploy, and then hopefully we can see a container starting on this local machine here. So let's see. I'll just go back to this one. So I can say docker ps, and we can see that there's one container running, which is the actions runner, and soon hopefully we will have 2 containers running on my machine. And now it goes to deploy staging and deploy local Docker, and I'm not caring about the Kubernetes deploy and the test. I'm just going to check this one. And now if we go to here, we can see now that running job, and it has started and it has already succeeded. We can check here with docker ps, and now we see that we actually have a new image running on this machine, which is the image from the latest release image from the GitHub Docker registry. So let's go back to the web browser, go to localhost, and press 8085, and voila, there we have it. And now you can see this has changed a little bit. It says initial people counter 0 because we don't have any here. We can press on these and nothing really happens very much. I can press load people, but nothing happens because there are no people. So I need to log in to add some people to this system. And now I press login, I get redirected to this login page, and I can say raboof, and password is 1234. It doesn't matter whatever I do. Login, and now you can see I'm logged in as raboof. The login button has changed to log out, and I can suddenly add people. So we can say here Reodor Felgen, age whatever, 67, height 150, whatever, save. And we added him. I also added options to edit and remove people, so now I can say foo bar save, and now we get the graphs. And if I do a reload here, I'm still logged in, but now if I load the people, I will get things. So I have a database in the back end. Everything is running nicely, and you see that the initial people count is 2. And then I can of course log out and so on. So this is it. This concludes this course. Now there's not really much more. Oops, I pressed the wrong key. There we go. Now it's just the exam. I will have the exam ready by Monday. I think you, if all goes well, you will have the exam delivered by next Monday. And I will also record, as I have promised, a few more lessons on functors and applicatives and monads and monoids. But that's it. Now you are full-fledged functional programmers. Congratulations and good luck. Bye bye.